All right, you guys, for the sampling distribution to describe it, you want to do SOCS. So you've got shape, and then outliers, center, and spread, but you don't need to do outliers. So for the shape, for proportions, it's NP greater than or equal to 10 and N times 1 minus P greater than or equal to 10. So for this one, we do 80 times 60%, which is 48, and 80 times 40%, which is 32. For the other sample, we've got 80 beads, but 48% were red. We get 38.4, and 80 times 0.52, so 41.6. All are at least 10, which means the shape is approximately normal. Okay, for the center, be sure you show this notation. I will check this on the test. So mu of p hat A minus p hat B. So be sure you do bin A minus bin B. So 60% minus 48% is 12. And our spread, same thing with your notation. Be sure you show that. We do separate p's on this one. So this would be p times 1 minus p over n, and the other p times 1 minus p over the other n. These just happen to be the same sample sizes, all right? And we get 0.078 for our typical distance from the mean. All right, for this one, you guys, we want to find the probability that bin B is higher. They told us to subtract in this order. So notice I'm doing the probability of the proportion of A minus B being less than 0. So why am I doing less than 0? If bin B is higher, then I'm just looking for a negative number if I'm subtracting in that order. And we can do norm CDF because we know the shape's normal. Lower bound, a big number that's negative, up to 0. We've got our mean of 12% and our standard deviation that we found above of 0.078. And you should get 0.062. All right, so here we have our election results, our males versus our females who voted for Obama in 2008. Do we have convincing evidence? So that's a significance test that you need to do here. So for your state, be sure that all of your P's have no hats on them, okay? Every time you're talking about state, you're talking about the true proportion. So our null hypothesis would just be that there is no difference between the males and the females. So you can say PM equals PF or PM minus PF equals 0. The alternate is that it does not equal 0. They just say, is there a difference? They aren't leading you in a direction, all right? And then be sure you define each. So PM is the true proportion of male voters in the city who support Obama. And PF is the same thing, but for females. Our alpha is 0.05. For your plan, first state the name of the test. So this is a 2-sample z-test for PM minus PF. We have 2 independent random samples. Be sure you have independent. Anytime you're doing 2 samples, you have to use independent. For 10%, we can say it's pretty safe to assume there's at least 2,500 male voters and at least 2,400 female voters. Then you got to check your large counts. All of them are greater than 10, so that's approximately normal. How do we get these numbers? NP greater than or equal to 10, N times 1 minus P greater than or equal to 10. Or you can just do 120, 250 minus 120, 132, and 240 minus 132. Either way, it tells us it's approximately normal. Okay, for the do part, I would like to see all of this work, even though your calculator can do a lot for you. Remember, on significance tests, you have to do P combined. All right, so this is P hat combined. We add our top 2 numbers from our P hats, the 120 and the 132, and we add our N's, the 250 and the 240. And that gives us a P combined of 0.514, which goes here. And then 1 minus that over your first sample size. Plus the same thing, P combined times 1 minus that over your second sample size. So you do have separate N's. Okay, you're subtracting in this order, males minus females. So be sure you do 0.48 minus 0.55 and then minus the null hypothesis of no difference. This gives us a test statistic or a Z of negative 1.55. Okay, why are we shading 2 sides? Because your alternate hypothesis was not equal to. So be sure you have a 2-tailed shaded normal curve here. Okay, and that means you're going to have to double when you do your norm CDF. So I did from negative 1,000 to negative 1.55. You could have done from positive 1.55 to positive 1,000. Mean of 0, standard deviation 1 is 0.0606, but you have to times by 2, which is 0.1212. Okay, you could definitely check this on the calculator, you guys. Just go to menu, statistics, stat tests. We are doing proportions. These two are for proportions. We're doing a 2 proportion Z test. And then you could plug in your males, 120 out of 250, and your females, 132 out of 240. We're just looking for, is there a difference? Okay, there's our Z, our P. They already have the P doubled, so if you use your calculator, don't double it. All right, and our conclusion, we have a p-value of 0.1212, which is greater than alpha, so we fail to reject the null. We do not have convincing evidence to conclude that there is a difference in the proportion of male and females who supported Obama. Okay, for part B, you can just show the interval part, the do, and the conclude. All right, so for your interval, you guys, you subtract in the same order your statistic, plus or minus your Z star. Some of you are doing this wrong. Be really careful if you're doing 95% that you do not plug 5% in for your inverse norm area. You have to do 5% divided by 2, 0.025. And then for your standard deviation formula, this is where you have separate p's. So don't use p combined. Be sure you have a 0.48 and 1 minus 0.48 over 250 and a 0.55 times 1 minus that over 240. Okay, we can get this on our calculator as well. So if you go to menu, statistics, and this time go to confidence intervals, again, proportions, 2 proportion Z interval, and we can plug in the same thing, 120 out of 250 and 132 out of 240, and we are doing a 95% confidence interval. And we've got our answer here, and that's all we need. Okay, and then interpret it. We are 95% confident that the interval from negative 0.158 to positive 0.018 captures the true difference in proportion of male and female voters supporting Obama in the city. So you guys, is this evidence of a difference? No, because 0 is included in the interval. So just like our significance test told us there really wasn't a difference between the two, so did our confidence interval because 0 is included in the interval. Okay, 10.2 is all means. So there's your basic formula for a confidence interval because it talks about finding the standard error in part A. So just a reminder that just this piece right here is the standard error. If you include the T star, it is called the margin of error. So be careful what they ask for. So this one's just the standard error. So we take the sample standard deviation squared over the sample size of 30 plus the other standard deviation squared over the sample size of 30, and we get 2.08. Okay, 99% confidence interval. So for this one, it's our sentence. We wish to construct a 99% confidence interval for mu1 minus mu2, and be sure you define them. mu1 is the true mean pulse rate of patients similar to those in the experiment who take beta blockers, and mu2 is the same thing for people who don't take beta blockers. So be sure you said similar to those in the experiment, since we have random assignment in this one, all right, instead of random sampling, which means we do not need to check 10%. Okay, so this is called a 2-sample T interval for mu1 minus mu2. Be sure you have T because we were doing means. And instead of independent random samples, you need to say that they were randomly assigned to treatments. Okay, both our sample sizes are 30. Thank you. We don't have to check the graph, so normal is satisfied. Again, if you're doing proportions, do NP greater than or equal to 10, but for means, we just check greater than 30. Okay, so here's what you can plug in. You can just plug in this work right here. X bar 1 minus X bar 2, 65.2 minus 70.3. Plus or minus, you do not have to state T star because we don't know our degrees of freedom until we run it on the calculator. This 2.08 comes from what we already did right here. Okay, if you wanted to show that, you can. And then we need to get this on our calculator. So this time we go menu, statistics, confidence intervals. The first 4 are all for means. We want the 2-sample t interval, and we're plugging in statistics. Okay, x bar 1 is 65.2, and that one has a standard deviation of 7.8, sample size of 30. Okay, the other x bar is 70.3, and a standard deviation of 8.3, sample size of 30. And they asked for a 99% confidence interval. Don't change pooled, and we get our answer. Pretty sure it did something weird. All right, so we should have gotten this. So here's my confidence interval, and you must state degrees of freedom, you guys. Every time on the AP exam, be sure you state that. Okay, so we were 99% confident that the interval from negative 10.64 to positive 0.44 captures the true difference in the mean pulse rates of patients receiving beta blockers during surgery and those who take the placebo. And we should say for patients like the ones in the study, but if you did say it in the state part, I will give you credit for that. Okay, so is this evidence of a difference? No. 0 is included in the interval, so really that's not evidence of a difference. Okay, so if we were going to write a null and alternative hypothesis for the same situation, the null should be that it equals 0, and the alternate we're looking for less than because we want to reduce the mean pulse rate. All right. So the test statistic is determine the p-value, draw the appropriate conclusion. You really do need to run the whole test on your calculator because you don't know. I guess you could use the degrees of freedom from part A and do TCDF. But I decided to just run the whole thing as a test. So we go to menu, we go to statistics, we go to stat tests. Again, the first 4 are all for means. We want a 2-sample t-test. Plug in the stats again. Change your alternate hypothesis to less than. And we get our p-value. All right, it did give us the same t, so we know we're on the right track. You do need to state your degrees of freedom again, even though it's the same. And then draw your conclusion. So because the p-value is less than alpha, we reject the null, which means we have convincing evidence that the mean pulse rate of patients taking beta blockers is lower than the mean pulse rate of patients taking a placebo. So how come this one actually had a difference? It's because of the significance level that they used on this one versus part A. We used a 99% confidence interval. Okay,